I wanted to give just a few tips on Project 2 for those of you guys trying to take the next steps. It is a very good idea to, before this weekend, that is the weekend of, right now it is February 25th, and you want to make sure, that was a funny text file. So you want to make sure that you are on a trajectory to finish 2 weeks from Monday. So I think this weekend is a great time to get a lot done, particularly since we have this basics autograder that was described in class and will be added on Monday. So there are two big challenges in Project 2 that you're going to have to start thinking about a lot over this weekend. One of those two challenges is figuring out how to do basic tasks. For example, how do I draw a cursor? Or how do I draw multiple pieces of text to the screen? Instead of just having one giant blob of text, how can I have like a letter A here and here and here or whatever, right? Those are basic tools that you can use, right? Much like in my example, when I described the process of hello worlding, this is like learning all of the basic moves that one might use, and I guess I had an example of like judo, right? So you're gonna have to learn your basic moves, and then you're also going to have to figure out how to come up with a plan for your overall system. And you can actually do these two tasks separately, right? You don't have to know how to draw the cursor in order to figure out how to design your overall system necessarily. You can think about these things differently, okay? So I'm going to say that it's not a bad idea to list all of the classes you intend to use, as well as their instance variables. You might even list all of the methods in those classes, okay? And we'll do a little investigation of what such a design might look like. And then after you've done that, you can check to make sure that all the things you're supposed to do, supporting clicking and arrow keys and so forth, you can do them with your design. And of course, you may find later you need to revise things a little bit, but at least this way you have a big old document that explains how things are supposed to work so that you have something in English that you can understand and then come back and fix if you need to make any big changes. So let's first talk about this world of figuring out how to do basic tasks, right? So in the spec for the assignment, I discussed something I call hello worlding. Okay? So that's an example. Let's suppose you want to figure out how do I draw a cursor, right? How do I get this feature, right? This thing. How do I get that? Okay. Well, I'm going to suggest that you probably shouldn't do it by trying to edit your editor/editor.java. I think that's probably not the best way to go about it. I mean, it might be okay, but I think it's better to think about in a limited context. So you might, for example, create a file called draw cursor. Maybe we'll call it draw cursor in the middle of the screen .java. And literally all that code is going to do is it's going to pop up a window and you're going to have a cursor out there. There's going to be no controls, nothing fancy. You'll just have this happening, okay? And after you've done that, then you know the basics of how cursors can be drawn. That is a basic move in the judo that is our project, right? So once you know how to do that, that is a great skill to have, right, for the future. Okay. Now, when it comes to design, all right, so I've set up actually this design worksheet inspired by discussions at office hours. And so what I'm going to do is go through a design with you. And basically what you can do in this worksheet is list all your classes and your instance variables and everything that you think is interesting. And then make sure that it obeys the key runtime constraints. So if we look actually at the project spec, right, there's this notion that the data in your data structure needs to be stored such that characters can be added to or deleted from the current cursor position in constant time, even if the cursor is somewhere in the middle of the document. Okay? And so we'll give an example of how we can analyze a particular idea to see if that's true. So that's an important thing you should do. We also have a couple of other constraints here. I just changed one a little bit to make it more clear and more consistent. But you will also need to store information about how information is displayed on the screen. And that's whatever you want to do. And in that case, this data structure, any updates to it can take linear time. That's totally fine. Okay. And then finally, there's the third constraint, which is that moving the cursor around. That is, if you press the arrow keys, you click, then that should take only constant time. Now there's a note though that every line, because the window is only so big, right here, since each line has a constant length, then that means that basically your runtime can be proportional to the number of characters in the line. So what I mean by that is, let's say we have a file like this one, and I press the down arrow, it is totally fine for it to take as many characters as there are in this line right here, okay? Because that's a constant, because this window is only going to be so big. I cannot have a line that is linear in the length of the file, if that makes sense, right? Everything has to be on separate lines because of word wrap. Okay, so that's our time constraints. So maybe to understand those time constraints and to understand the design process, let's discuss a specific design that we're going to put together, okay? So we're going to start from a blank one. And so basically what this is, feel free to go to this document and, okay, well, I'll fix it later. But feel free to go to this document, and then you can do File, make a copy, and keep your own copy in Google Docs, okay? So in my case, I might imagine that I'm going to have a class called Editor, okay? And in order to store the characters that someone tries to insert or delete, I might create an object that I'm going to call a text buffer, okay? And I'm going to have here a class called text buffer. What is a text buffer? Well, it's going to contain a string which is called entered text, and this is everything the user has typed. So there was a note in the spec somewhere saying, watch out for strings, and we're going to go through why it might be dangerous. Okay. I'm also going to have, let's say, after a bunch of thinking, I decide, oh, I need to keep track of the current position. Okay. I might have a method called something like add character, and I can give it a character x, and this adds the given character to the string in current position. Likewise, I might have delete char, and that deletes the character at the current position. Okay? That's something I might imagine. I have a class called text buffer that's going to do the job of me being able to add and delete things. Now, what's really nice about this design is it gives us layers to our overall architecture of our program, right? We have the editor at the top level. It has a variable called text buffer. Oh, well, it's called buffer. It's a type text buffer. And it can defer all of the hard work to buffer method. So for example, when I try and insert something into the text, what happens? Okay. So suppose I'm doing that. Let's maybe scale this up a little. So suppose I am doing an insertion. So what I might do is I might say, user types a character. We call buffer.addChar, whatever the thing is they've typed, let's say s. And we'll give an example, however you want to do it. We call it buffer.addChar s, and in that case, the text buffer class updates its entered text variable to contain the letter s at position, current pause, and current pause is incremented by 1. You might write something like that, okay? And that might describe how insertion and deletion goes. Does anything else need to happen in our editor? I don't believe so. Okay, so that's all I got here. All right, now we need to make sure, though, one important thing is to make sure that we're obeying all of our runtime constraints. So I might say how insertion works. I'm just describing how it works. So I might also have an analysis of the runtime, insertion runtime. Okay, so there's a fact in Java that strings are immutable. We cannot take a string and expand it, right? It's just impossible. So it turns out that if you actually try and implement this thing, maybe you won't catch this when you make your design. Maybe you'll just say, oh, it's fine. But whenever you start writing your code, you may come to realize I cannot just change a character out in a string. And so instead, what I'll observe is that because strings are immutable, in order to insert a character, we need to build, how about this? In order to insert a character into a string of length n, we need to build a new string of length n+1 that contains all the original characters plus the new one. And that, of course, is going to be a linear time operation. And that's why using a string is dangerous. It does not obey this rule. Okay? We could also write how delete works, but I won't do it here, though I do have it in this example here, so if you want to see it, there you go. And so that's deletion. Right. I'm not going to write it out. Okay? So that's an example of a design that's faltering, but for the sake of argument, maybe let's keep going through the design, right? If this is what we get, if we have a class called editor with one variable called text buffer and all of these, this right here gives us some insight to how my program is going to work. Are there other methods here? Maybe, of course, but we're only listing the ones that seem really important to understanding all of our commands. Okay, so how about arrow keys? How would that work? So let's say user presses down arrow. So when you're doing a design document like this, whenever you're just trying to understand it, and especially as a student, you're going to write it out in some way that might involve, or you might consider writing it out in some way that involves a very specific example. Like here I said entering the character S, here I'm saying entering down arrow. And by doing that, you can keep the scope of all the things you need to think about small enough that you can really think about it and say, when I push the down arrow, what here needs to change? Okay. So if you just ask that question, what changes out of all this? Well, this is the thing that changes. We need to change the current position. Enter text doesn't change. The buffer variable is not going to point at anything new. This is what I need to fix. Okay. So user press down arrow, need to update current pause. Okay. So what we could do then is say, oh, okay, well, maybe I'll write a method, I guess, in text buffer. I don't know, something like that. Let's see. So we could say, where do we want to put it? So we think a little bit and we say, so I push down arrow. So where do I want that method? So I don't know, maybe I'll try and write it up here. Editor, I want to do, let's call it, I don't know, handle down arrow or something like that. Maybe I'll just try that. I'm just making it up as I go. So I make up a function called handle down arrow, and what it's going to do is make some calls to text buffer. Okay. So right now the API, that is the interface, the application programming interface for text buffer, doesn't give us the things that handle down arrow will need. So we might think about it. What does editor need to do in order to handle down arrow? What does it need from text buffer? Well, maybe it needs something like a get, let's call it car get int I. And maybe that does is it returns the ith character of the enter text. Okay, why might that be helpful? Well, let's see if that's enough, right? So whenever we do class editor, we say we call handle down arrow. In turn, editor will iterate through the text buffer using get, checking the widths of each character using JavaFX magic, and when that length exceeds window length, then we will increment a local variable y. Oh, okay, I guess I forgot to do that. So handle down arrow. Okay, so maybe I'll make a little note here. Handle down arrow, how it works. Set x and y variables to 0 and to 0. Editor iterates through the text buffer using get, checking the width of each character using JavaFX magic, and incrementing x as it goes. And when that length exceeds the window length, then we'll increment a local variable y and set x back to 0. We repeat until we have reached current pause. Okay, well now I realize, oh, well, current position isn't quite available. Presumably this is private. It's not good to give away your variables, so I might also have int current pause, which returns the current pause. So that's another thing I might need in order to support this operation. Okay, so we'll repeat until we've reached the current pause, and at that moment we'll record the current x and y someplace. Okay, we then continue iterating through the text buffer until we hit the same x again, and in so doing we will update. And so I have a design in mind. I don't know if this is making sense, but this is roughly what you might try and do. Okay, so it's not super important that you're understanding exactly what I'm doing here, but when we hit the same x again, according to JavaFX, we will record the new cursor position. Okay. So this design, I mean, it makes sense to me. Might not make total sense to you because I had a certain thing I was thinking about, but as long as that's good enough for you to understand, so you can look at all this and say, okay, I know what I'm trying to get. You know, I have stuff I can really sink my teeth into. That's going to be the important part. Because when you later implement, you want a clear idea where you're going. And sometimes it's not totally clear until you try and sit down and program, and then you realize, oh wait, this doesn't make sense, and that's totally fine. Okay, happens. All right, so at that point, right, we could look at this and say, all right, how long is this going to take though, right? Even if you didn't quite follow that, basically what I was saying is that whenever you push the down arrow, you're going to step through all of the text up to that point, and I'm going to keep track of X's and Y's and God knows what. And then finally we get here and we're done. And somehow we can update the cursor, okay? And let's say a local variable. Or sorry, how about an instance variable called cursor X and cursor Y. So that says maybe I need int cursor X, int cursor Y. And those seem like handy things. All right, so I'll do some kind of magic to set those. Okay. So now that we have a rough picture, we can say how good is that for runtime though. Okay. So I'm going to make a note here that handle down arrow runtime. Well, it's going to take takes time proportional to the character number in the file. So if we click at the end, it takes runtime linear in the file name or in the file length, and therefore is too slow by our constraints. So if you tried to do some kind of brute force approach like this, it's going to be too slow. And you could continue to do the same thing where you say you're changing cursor position with clicks. So I won't say this will be like similar to arrow keys. And then finally I might have something like rendering text. Now here when we render text, what I'm going to observe is that there is going to be a lot of overlap compared to what I had here. In this case, whenever I'm trying to handle the down arrow, I'm going to iterate through the whole text buffer, checking the width of each character. In a sense, I'm actually re-rendering everything. And so there's a bit, I'm going to make just an observation. This code is going to be awfully repetitive compared to the last two methods, or the last two tasks. Compared to clicking arrow key handling, right? So in a sense, clicking and arrow key handling, they're doing like a fake kind of rendering as you go, which might give you some insight into how you might add other classes. So that's just a broad picture. And, you know, there's no right way to do this, basically. But I do think that trying to take notes that you can understand, even if it's not this exact format, that it can actually help you quite a bit in terms of understanding what your design is supposed to be and making sure that you obey your runtime constraints. So consider building such a thing. Maybe if you're doing it on paper, you can draw out diagrams. And one day when I actually have my computer set up so that I actually draw things out, I think I could do an even better job than this right here. Okay, but basically the gist of it is that if this is my set of instance variables, we're going to run into trouble, right? So the data structures, remember this quote from one of the very first days of class. Bad programmers worry about their code, right? They're getting concerned about, they're getting too wrapped up and thinking about these things. How do I draw a cursor? How do I draw multiple texts? Those things are important, but actually much more important is this, picking your instance variables. Because the instance variables that you pick are going to drive your entire design. These are the things you're changing. Whenever you push any buttons, whenever you do anything, you're ultimately just updating these instance variables. And so it's extremely important that you pick the right ones. And it's going to take a little while. It might take a few design iterations. You might decide to come up with something and realize it's too slow. And so in order to speed things up, I encourage you to talk to other people. You can maybe compare designs. Please don't just give them away because that's just bad for people's learning experience. But yeah, please do discuss. So I hope this video was useful. I know that this part isn't awesome, right? But yeah, I'm under a lot of time pressure right now, so I don't really have the time to like really nail a video. But wanted to get something out there since, you know, I know this is quite a challenging project. And I might try and squeeze out another video sometime early next week or midweek for things that come after this. Okay, but that's a rough picture how you might approach the design process, and I will see you in class tomorrow.